Hello, ladies and gentlemen. Time for a little lesson on how to do this assignment, the linear versus exponentials tables and situations. So this is what the assignment looks like. But before we dive into it, let's go back to those notes. So from the previous time, we had these notes here where we were talking about differences and similarities between linear and exponential functions. So both of them do have a initial value or y-intercept. For the linear function, if you're looking at the equation, it's the b value. If you're looking at the exponential one, it's the a value. But what makes them different is the linear ones have a constant slope, and then the exponential ones have a constant growth factor. So if you have a constant slope, that means you're adding or subtracting the same number each time, and a constant growth factor means you're multiplying by the same number or dividing by the same number each time. And so those are the definitions we're working with. Linear functions add or subtract the same number each time. Exponentials are multiplying or dividing by the same number each time. But what you need to do on today's assignment is to look at tables and situations and determine if they're linear or exponential and provide a reason why. And so if we go to our notes, if you go to the back, it has tables. And when you're looking at tables, you need to keep track of a few things. So first thing you need to keep track of is what is going on with your x's and what is going on with your y's. And you do have to look at both of them, even if you're just glancing at the x's and be like, yeah, it's all add 1, just to make sure, because sometimes your x's aren't doing the same thing each time. In that case, you do have to pay attention because it changes how you respond to things. As I look at this table, it looks like it is subtracting 10 each time with these y's here. So subtract 10, subtract 10, subtract 10. And so since it has this pattern of subtract 10, subtract 10, subtract 10, subtract 10, that makes this linear, which you might have guessed because it was in the left column here. And it has a constant slope, and that slope, in this case, remember to get slope, it is the rise over run, also known as the change in y or the change in x. That triangle just means change in. So if I was looking at this table, the y's are going down by 10, and then the x's are going up by 1. If you want, you could put the plus there, but you don't really need it. Which means we got negative 10 over 1, which equals negative 10. So our slope is going to be negative 10. You can jump to other tables. Let's go to this one below here. Once again, I'm looking at my x's, and I'm noticing it is not just add 1 each time. It's actually adding 2 each time. So add 2, add 2, add 2, add 2. And then my y's here are, well, it looks like going from negative 2.5 to negative 1.5 is just adding 1. So it's adding 1 each time as I go down here. All right, negative 0.5 plus 1 is positive 0.5, and 0.5 plus 1 is 1.5. It's just adding 1 there. So if I were to get my slope on this one, again, it's the change in y over the change in x. It's a bad triangle up here. And the y's are going up by 1, and the x's are going up by 2. And so my slope here is going to be 1/2. And it's very important that you can recognize what's going on with the table. How are the x's changing? How are the y changing? Because if you jump over to these ones, they act differently. Again, I'm going to be double checking these changes here in the x's. It looks like it's just add 1 all the way down, which is good. You just got to check it. But my y's here are not adding the same number each time. All right, this would be like plus 6 and then plus, 24, and then plus an even bigger thing. So it's not adding the same thing each time. Well, our next thing to try is it multiplying by the same thing each time. So 2 times 4 would give you 8. Is it times by 4 the next time? It is. So it's all times 4. And you should test just to make sure, are these all times by 4? And they are times by 4. And so this is what we call a constant growth factor. As it said up here, table show constant growth factor. So this is all multiplying by 4. Multiply by 4, multiply by 4. So the growth factor is 4. Let's look at this next table. Once again, you double check your x's, see what's going on. It looks like this is all just add 1 as you go down the table. But here with our y's, it is not just adding a number each time. this is actually getting smaller, and it's not subtracting the same number each time, right? Going from here to here, well, that'd be subtracting 14. But going from here to here is not subtract 14. It's doing something completely different. And so we're going to check to see if it's timesing by the same number each time. Well, this is getting smaller, and so it might be easier to think about, well, what is it dividing by? How do I go between these numbers here? If you are unsure what it is dividing by, you can just take any number and divide by the previous one. Or, sorry, if you want to figure out what's timesing by, you can take any number and divide by the previous one. Or you can just think, okay, well, take this and divide by the next one, and that'll tell you what it's dividing by. So you only got 21 divided by 7, it gives you 3. So it's dividing by 3. Or if you're looking at the other way, you need to be able to figure out what it is timesing by to get this. So this all has it is divide by 3. Well, if you're going to divide by 3, that is the same thing as timesing by 1/3. 1/3 is 1 divided by 3. So if you times by 1/3, it's times by 1 and divide by 3. So that's effectively going to divide by 3. So that's why here it's saying that your growth factor is 1/3 because it's timesing by. So you need to be able to identify what it is timesing by. That's a big part of being able to get growth factor. So even if it's dividing by 3 or dividing by 7, or if it's dividing by 12 or dividing by -2, that tells you the growth factor, what you're timesing by, is 1 over that number. So there you go. You got to be able to look at tables and be able to figure out the difference between, are they have a constant, is it changing the y's the same amount each time, like add 10 or subtract 10 or add 1 and stuff, and figure out if it's multiplying or dividing by something. So that's a big part of it. So let's go to your actual assignment. So it's got this one. So up here, you got some conceptual questions. This is just to remember the definitions of linear versus exponential. So how can you tell if a situation or table has linear change? It has a constant slope. That means x's and y's change the same way. Okay. And then how can you tell if a situation or table has exponential change? That is a constant growth factor. That means it is multiplying or dividing by the same number each time. Okay. I'm going to leave it to you to answer 3. Do you want your money to grow linearly or exponentially? So yeah, just kind of decide to think about it. But yeah, you're confronted with a bunch of different tables and situations. So you got lovely little situations here. You got to read the situation and think about how is it changing to deal with those. So I'm not going to do any of these table ones. We just looked at a couple table ones to figure out why they're linear and exponential and stuff. So let's look at a few of these situations. So let's look at 5. Tamara is digging a hole to get to China. Probably not going to work, but she can try. She has gotten 8 feet down and can dig about 1.5 feet each week. So you think about what's happening. So as the weeks continue on, so you got another week has passed by, how much has things changed? Another week passes by, how much have things changed? Well, each week it's just going down by, well, it's getting 1.5 deeper. So you got 8, you're starting with 8, and then each week it's add 1.5. So it makes this kind of expression here, or I can actually turn it into an equation. So it looks like this. That looks awfully familiar. Hopefully you're recognizing that this is linear, and this is just adding 1.5 each week. Okay, that is a constant slope. Okay, it has that same change each week. Just add 1.5, add 1.5, add 1.5. Or if you're saying this is all negative, right, below ground, then it's minus 1.5, right? Negative 1.5 is kind of slope going deeper. Okay, so you have to think your way through what is happening in that situation. Sorry, let me jump to the next side of the page here. Let's see. Let's look at something like 13, a nice long one. Try not to panic. And to deal with these, you do have to remember some of the things from our previous units about, if you have percent change, like on 18 here, if you're losing 10% each minute, right, that is going to be exponential change. We're going to come back to that. 13 here, this one is also going to be exponential. And that is because of right here. You're dropping 2/7 each week. So if you have a lot of people and you lose 2/7, all right, you still got some people left. But then the next week, if you lose 2/7 again, you're losing a portion of it each week. And that's very similar to like losing a percent each week. So whatever amount is left, you're taking a portion of it. And so it's going to be different each week. We're not losing 2/7 of a person each week. Of every 7 people, 2 of them are gone each week. That's going to shrink and shrink and shrink. And eventually get to the end where you only lose a few people, but at the beginning you're losing hundreds of people. And if you have something like that going on, that's definitely going to be exponential. So our reason here, it has a growth factor let's actually figure out what that growth factor is. So if you lose 2/7 of the people, what portion is still there? Hopefully you can remember that 1 minus 2/7 is going to be 5/7. So we got a growth factor of 5/7. 5/7 are still there, and each week you keep 5/7 because you're losing 2/7. Well, let's go over to 18. This one, again, we're losing a portion every minute. So that's going to give this make this exponential. And if you lose 10%, think about what percent is still there. You take 100% and you minus your 10%. You still got 90% of the people there. 9% of the altitude left still. And that means you're going to have exponential change there. And that's actually going to be our growth factor, but we got to write it as a decimal. You got to still be able to convert decimals to, percents to decimals. We have and we'll put that constant growth factor. Growth factor of, 0.9. All right, 90% is 0.90 as a decimal. If you're trying to figure out how much it's going to be in 1 minute, you're going to take what you currently have and times by 0.9 because that's 90% of what you once had. And so that's what's going on throughout this assignment. You just look at tables, figure out what's going on. Look at the situation, figure out what's going on. Is it changing linearly or exponentially? And yeah, you should be able to work your way through. Use buddies if you get stuck, or even your teacher might be able to help you out with it. Good luck.